If you go outside on a clear night and look up, your eyes are naturally drawn to the light. You see the stars, the planets, maybe the moon. And we're sort of taught from a young age that this is what the universe is, a collection of bright objects. We think of planets as being tethered to their suns, like they're part of a permanent family. But that's only half the story. Astronomers have recently started to realize that the dark space between those stars isn't actually empty. It's actually crowded. In the gaps where we thought there was nothing, there are billions of worlds just drifting. We call them rogue planets. And I mean, think about that for a second. Billions. There are likely more of these worlds in our galaxy than there are actual stars in the sky. It kind of changes how you look at the night sky, doesn't it? You're not looking at empty blackness. You're looking at a sea of invisible worlds that don't have a sun to light them up. Now, these planets weren't born in the dark. Every single one of them was born in a nursery of gas and dust, just like Earth. They had a home. They had a sun that gave them light and warmth. But space it's a bit of a chaotic place, especially when a solar system is young. Imagine a bunch of giant planets, things way bigger than Earth, all pulling on each other with their gravity. It's like a massive, slow-motion game of billiards. Every once in a while, a smaller planet gets caught in a gravitational tug-of-war. It gets swung around a gas giant like Jupiter, picking up more and more speed, until finally, it just breaks free. It gets kicked out of the nest. It leaves its sun behind forever and starts a journey into the deep freeze of interstellar space. At first, the planet would still be warm from its birth, but as it drifts further away, its sun would start to look like just another tiny star in the distance. Then, eventually, that sun would fade into the background until the planet is truly, completely alone. It's traveling incredibly fast, literally millions of miles per hour. But because space is so ridiculously vast, it feels like it's just hovering. It's just sitting there in a temperature that is barely above absolute zero. It's a world without a day or a night. It's just a permanent, deep twilight. And it's out there right now, somewhere in the dark, just existing, belonging to no one. So, how does a whole planet, something weighing trillions upon trillions of tons, just get thrown away? It feels like gravity should be stronger than that, right? Like it should hold everything together in a perfect, neat little circle. But actually, gravity is kind of a double-edged sword. In the early days of a solar system, things are incredibly crowded. It's not the stable, quiet place we live in now. You have hundreds of protoplanets, all trying to find their lane, all bumping into each other's personal space. And it's the gas giants, the Jupiters and Saturns of the universe, that really run the show. Astronomers call this gravitational scattering, and it's a lot more intense than it sounds. Imagine a smaller, rocky planet, maybe something like Earth or Mars, looping around its sun. Everything is fine for a few million years. It has a routine. But then its orbit brings it just a little too close to a massive gas giant. Now, a planet like Jupiter has a massive gravitational footprint. As the smaller planet falls toward the giant, it starts to speed up. It's literally stealing a tiny bit of orbital energy from the gas giant. It's like a cosmic slingshot. The smaller planet whips around the giant at an impossible speed. If the angle is just right, or I guess in this case, just wrong, the planet isn't just moved to a new orbit. It's accelerated so much that it hits what we call escape velocity. It's moving so fast that the sun's gravity, as big and powerful as it is, simply can't hold on to it anymore. The leash just snaps. And the crazy thing is, the gas giant barely even feels it. To the giant, the little planet is just a pebble. It doesn't even notice the loss. But for that smaller world, its entire destiny has just been changed in an instant. It's been launched on a trajectory that leads straight out of the solar system and into the empty space between the stars. It's sort of like being thrown off a merry-go-round that's spinning a little too fast. 1 second you're part of the system, and the next you're flying off into the dark. And once you're out there, there's nothing to slow you down. Space is a vacuum, so there's no friction, no resistance. You just keep gliding through that blackness for millions, maybe billions of years. Just think about that journey for a second. The sun you used to orbit starts to shrink. It goes from a warm, blinding disk to a bright star, then to a dim star, and finally, it's just another point of light in a sea of billions. You're now a silent traveller. You're passing through a void so fast that you might not come within a light year of another object for eons. You're just out there, moving through the deep freeze, never to feel the touch of a sunrise ever again. But you'd probably assume that once a planet is kicked away, it just becomes a giant, frozen tomb. And if I must tell you, on the surface, that's exactly what happens. The atmosphere likely collapses, and everything turns into a layer of glittering frost. But if you could look deep beneath that frost, things might actually be somewhat different. You see, planets aren't just warmed by the stars they orbit. They have their own internal batteries. Down in the core of a planet, including our own Earth, there are radioactive elements like uranium and thorium. As those elements slowly decay, they release heat. Lots of it. And because a rogue planet is sitting in the vacuum of space, that heat doesn't always just vanish. If the planet is large enough, or if it has a thick enough layer of ice on top, that ice acts like a massive thermal blanket. It traps the warmth inside. It's actually kind of cozy if you think about it. And I hope as you're listening to this, you are very cozy, by the way. And so you have this world that is incredibly cold on the outside, but has a warm, glowing heart. In fact, some scientists think that rogue planets could have massive, liquid oceans hidden beneath miles of ice. It's pitch black, sure, but it's liquid water. There could be volcanic vents on the ocean floor, pumping out minerals and heat, just like they do on Earth. It's a strange thought, but there might be more life in the dark gaps between stars than there is on the planets orbiting them. We just can't see it because it's tucked away, insulated from the void. But we've just been talking about planets, these relatively small worlds. But it actually gets much, much bigger than that. It's not just planets that get kicked out of their homes. Sometimes it's entire stars. Astronomers call them intergalactic stars. And the way they get ejected is, well, it's a bit more, well, no light way to put this, but violent. To kick a star out of a galaxy, you need a monster. You need the supermassive black hole at the center of the galaxy. Imagine a pair of stars orbiting each other. As they drift through the crowded center of the Milky Way, they get a little too close to the black hole. Now, instead of swallowing both stars, the black hole sometimes performs a bit of cosmic surgery. It captures one star, pulling it into a tight, permanent orbit. But that energy has to go somewhere. So it transfers all of that massive gravitational momentum to the second star. The second star is suddenly flung outward at speeds that are almost impossible to imagine, fast enough to overcome the gravity of the entire galaxy. This star is now on a one-way trip into the great nothing. As it leaves the spiral arms of the Milky Way behind, it enters the intergalactic void. There's almost nothing out there. No gas, no dust, just a lonely sun burning away in a place where it was never meant to be. That star could actually have its own planets. Imagine a rogue planet that managed to stay tucked into its orbit while its parent star was being kicked out. Those planets would be traveling with the star into the darkness. If you lived on a world like that, your sun would still rise and set every day. You'd have warmth. You'd have light. But if you looked up at the night sky, it wouldn't look like our sky at all. There wouldn't be a single star. No constellations. Just a deep, endless, ink-black ceiling. Except maybe for a few tiny, ghostly smudges in the distance. No offense to myself, of course, with the images I generate for you in each video. And so, it's a different kind of lonely. So let's just try to imagine what it would actually be like if you could stand on the surface of one of these rogue wilds. First off, it would be cold. Not just winter cold, but a kind of cold that we don't really have a word for. If the planet doesn't have a thick atmosphere to trap heat, you're looking at temperatures so low that the very air would have turned to snow long ago. You'd be walking on a crust of frozen nitrogen or methane. And it would be dark. But not dark like when you turn off the lights. On Earth, even on the darkest night, there's a glow. But on a rogue planet, the darkness is heavy. If you looked up, you wouldn't see the Milky Way. It would just be a perfect, unbroken black. Think about this. If you held your hand out in front of your face, you literally wouldn't be able to see it. There is no light source for millions of miles in any direction to reflect off your skin. You'd be standing on a solid world, but your eyes would tell you that you're floating in cold, hard nothingness. But let's say, for an example, you stayed there a while. Maybe your eyes eventually adjusted to the absolute limit of what they can see. Gradually, you might start to notice these tiny, faint, ghostly clouds. They aren't stars, they're galaxies. From the middle of the void, the Andromeda Galaxy, or our own Milky Way, would just look like little smudges of light, like someone took a paintbrush and left a tiny, translucent stroke on a black canvas. You'd be looking at 100 billion stars, all condensed into a tiny spot the size of a grain of sand. Everything that has ever happened in human history would be contained in one of those little, faint smudges. And you'd be viewing it from the outside. It's a strange perspective. You're in a place where time feels like it has absolutely stopped. There's no sun to mark the days, no seasons to mark the years, just the planet's internal heat beneath your feet and the infinite, quiet distance above you. It's probably the most peaceful place in the universe, in a weird way. Just you and the deep, dark vastness of everything else. Me personally, I'd rather be on a tropical island, drinking something fruity with an umbrella. But you do you. And so, what happens to them in the end? These planets and stars that have been kicked out into the dark. Where is their story actually going? The answer is kind of elegant in a way. Because they aren't near any stars, they aren't being bombarded by radiation. They aren't being pulled or stretched by the gravity of other planets. In the deep void, they found a stability that we don't have here in our busy solar system. They are the ultimate survivors. While stars back in the galaxies are burning through their fuel and eventually exploding or collapsing, these rogue worlds just endure. They can drift for trillions of years. Eventually, the internal heat we talked about that radioactive battery in the core will start to run low. The oceans beneath the ice will slowly, very slowly, begin to freeze solid. The planet will become the same temperature as the space around it. But even then, it doesn't disappear. It keeps gliding on, a perfectly preserved time capsule from a solar system that might have died out billions of years ago. It's strange to think about, but these outcasts might actually be the last things left in the universe. Long after the last stars have flickered out and the galaxies have drifted too far apart to see, these lonely, frozen wilds will still be there, just floating in the dark. And I think there's something weirdly comforting about that, don't you? It's just that the idea that even when things seem empty or lost, they still have a place. They still exist. They're just following a different path than everyone else. As you're lying there now, just think about that vastness for a second. Think about the distance between those tiny smudges of light. It's so big that there's plenty of room for everything to just be. You don't have to keep track of the time. You don't have to worry about the sun rising or the day starting. Out there, in the void, there is no clock. There is no rush. There is just the steady movement through the dark. Everything is far away. Everything is muffled. And everything is exactly where it's supposed to be. Just like those wilds, you can just drift now if you haven't already. The journey is long, but it's very, very calm. So, let your mind continue to wander into that space between the stars. It's big enough to hold every thought, every dream, and every bit of the quiet you need. The universe is vast, and it's okay to just be a small part of it, and you can rest with that.